Hey guys, Dr. Brown here with Kubo Math, coming to you from Tarlac City, Philippines. And tonight it's the second in a three-part series where we're looking at integrating. The first video was sine squared. This video will be integrating sine cubed x dx. But then the next video will take the results of these two videos and compare them to integrating sine to the n, which would make more sense to have a function with n equal to or greater. Then we don't have to keep integrating this over and over and over. And then we'll have future videos doing cosine, tangent, secant, cosecant, and do the same with each of those, ultimately get it to the nth power. So here we go. Integral of sine cubed x. You guys have probably done this a million times back in the day. All right, as did I. So let's break this in half and put it into two parts with the plan of integrating this by parts. Okay, so we can say, well, sine cubed is sine, and I'm going to put this sine x squared. You know this is sine x cubed. I wish they had written them all like this instead of like that. To me, that is confusing, but nevertheless. All right, so sine x squared times sine x, and we're integrating that with respect to dx. Okay, now let's break this into parts using the DI method, which I think is awesome, by the way. I wish we'd had that concept when I was in school before, because and I would encourage you integration by parts using the tabular method, DI method. There's millions of videos out there, many videos, maybe not millions, but many that discuss this procedure. You get exactly the same results as the old school way that we learned before, but it allows you to keep up with the signs easily. I mean, easily. It helps you organize all the data without having to write it over and over and over and over. So, and we'll go through a few steps of that. But look at your function here and ask yourself, which one can I integrate easily? Well, in this case, you could integrate both of them, but obviously sine x would be the easiest one to integrate. So now put the other one. So now I have sine x squared, and you're taking, you'll write plus, minus, plus, minus. We don't know how many we need, but let's just now differentiate sine x squared. Bring the 2 down, so 2 sine x, and 2 minus 1 just gives us that to the first power. Oh, now chain rule. Derivative of sine is cosine x. Whoop, chain rule. Derivative of x is dx. Okay. The integral of sine x is minus cosine x. Okay, so now, we multiply the diagonals and we integrate the row. The rules are, if you can take the derivative all the way down until you get a 0, that's your first stop. Second stop would be if you can see that you can integrate a row, you can stop. And then the third one would be if you end up with repeating functions. If you end up with repeating functions, that allows you to go back to the original problem and probably subtract that out and eliminate it from one side. And it's pretty cool. All right, so let's go with what we have here. We have sine x squared times negative cosine x. So this equals, I'll put the negative here. I'll put my sine terms first. Sine x squared times that negative cosine x. So sine x squared negative cosine x. Okay. Now we're going to integrate this row, but it's a negative times a positive, which is a negative, negative times negative. So I have two negatives, so that gives me a positive 2 times sine x cosine x, but I have it times another one, and that's cosine x squared. So 2, and this is an integral, 2 sine x cosine x squared, okay, dx. All right, so what do we do now? Well, if I let u equal cosine x, u equals cosine x, du equals negative sine x dx. So if I isolate the dx, I divide both sides by negative sine x, I end up with du over negative sine x equals dx. So now what do we have? We have equals minus sine x squared cosine x plus 2 times the integral of u squared times sine x divided by negative, or times du over negative sine x. Now I'm going to move this negative out here. Get rid of it or I'll lose it if I'm not careful. Okay, so u squared, the sine x's cancel, and I end up with minus sine x squared cosine x minus 2 times the integral, this integral of u squared du. So u squared, u 2 plus 1 equals 3 divided by 3. So I end up with 2 over 3 u to the third. But what is u? U is cosine x. So it's cosine x to the third. So cosine x to the third. I'll write it this way. All right, well, can I reduce this and do something with this cosine x third just to factor down a little bit? Well, yes, I could. Well, that's, let's see, let's get over here, work. Cosine cubed x is cosine squared x times cosine x, right? Well, I could change that cosine squared x into 1 minus sine squared x times cosine x. So now if I distribute the cosine x to the inside, I get cosine x minus sine squared x cosine x. Okay. Now then, so what do we have here now? We have minus sine x squared cosine x minus 2/3 times our cosine x cubed was all of this, right? So that's times cosine, heck, let's just go ahead and multiply it out. 2/3 cosine, or 2/3 times cosine x will be 2/3 cosine x. Okay, and now this negative 2/3 times negative sine, so that's positive. Negative times that negative gives me a positive sine, positive 2/3 sine squared x cosine x. Okay, now you'll notice I have a negative sine squared x cosine x and a positive 2/3 sine squared x cosine x. So if I add those together, I get a negative 1/3 sine x. I'm going to go ahead and put it back out, leave it outside like that for the moment. Cosine x minus 2/3 cosine x. So this term was minus one of these, and this was plus 2/3 of that same quantity. Gave me a negative 1/3 sine squared x cosine x minus 2/3 cosine x. Now if I put this back into the nomenclature that you normally see, it would look like this, plus c. And that, my friend, would be the answer for the integral of sine cubed x dx. It's minus 1/3 sine squared x cosine x minus 2/3 cosine x plus c. In the next video, we're going to take, instead of raising this to the 4th power, 5th power, 6th power, let's just take it to the nth power and develop the equation performing the integral of sine x to the nth. Once we do that, now we can take and plug in our results that we had when we integrated sine squared. We can plug in our results with integrating to sine cubed and see if we get the same thing. Okay, why are we doing this? Together we're trying to build a better tomorrow and do that through math. That's all for this time. We'll talk to you again soon. Hey, keep studying, guys. Talk to you soon. Thanks.